This is Unit 1, the Alphabet and Grammar of Geometry. Preview video 1.3, the Grammar of Geometry, Part 2. More about logic. Taking a look here, you should be watching this video on the 26th or the 27th prior to class on the 28th and the 31st. Location that you're watching this video, date and time. Don't forget a parent or guardian sign-off. Take a look at this page. I'd like you to attempt to complete this on your own and then come back with your red pen and check. Pause the video, do it, restart. Ready? Pause. Welcome back. Let's see how you did here. So this one, we wanted to take the conditional and write its converse, inverse, and contrapositive. Remember, converse is the switch, inverse is the negate, contrapositive is where we switch and negate. That little tilde-looking sign means to say the opposite of. So if you sing daily, then you have a happy heart. The converse, I'm going to make this real short here, is this. If you have a happy heart, then you sing daily. That is the converse. Inverse, you say the opposite. If not sing daily or don't sing daily. Then not a happy heart, or you don't have a happy heart. Contrapositive, you switch and negate. So if not or don't have a happy heart, if not a happy heart, then you don't or not sing daily. Check your work. Ready? We're going to solve for the variable. You weren't supposed to use a calculator, so step number 1 is we cross multiply, and we do not actually multiply in our heads. I always like to write it out longhand. That way you're less likely to make simplistic mistakes. And then we're going to go this way, 3 parentheses r plus 7. Next line, we're going to multiply that out, 35. Distribute 3r plus 21. Variables to one side, numbers on the other, so we're going to minus 21. And of course, that's going to be 4, and that's 1, and we have 3r. We divide by 3. Now, at this point, many of you were freaking out because, like, wait a minute, Miss Way, I don't have a calculator, and I didn't get, and you probably thought your answer was wrong. You're like, fraction, it must be wrong. Well, I got news for you, kiddos. Fractions are real numbers. Fractions are actual answers. So those of you got a fraction, yes, you've had the correct answer. Or if you turned it into a mixed number, 3 goes in there 4 times with 2 left over. Or some of you actually did this longhand and got a decimal. 6 repeating. It's fine if you leave it as an improper fraction. For that, I was simply making a point. Fractions are possible answers. Just because something's a fraction doesn't mean it's wrong. We're going to continue with our study of logic, something called inductive and deductive reasoning. By the time we're done, you're going to know these words. Say this out loud as I say them. Check them off. Inductive, deductive, law of syllogism, law of detachment, law of contrapositive, conjunction, and disjunction. Say those words again to yourself out loud. Alrighty here, I'm going to show you the difference between what's called inductive reasoning and deductive reasoning. Here we have a bunch of photos of golfers, various golfers. You see Tiger Woods here, Michelle Wie there, etc. So various golfers. Let's take a look at all those photos. A question for you. What piece of clothing do you notice in each and every photo? In each and every photo, there's a similar piece of clothing for every single one of them. Look at it, and I'd like you to take a wild guess. Write that down. You should have noticed in each and every photo, they are wearing a cap of sorts. Every single one of them, slightly different styles, but they're all wearing a cap. If you said hat, that's fine, it's no big deal, but cap, head covering, something to keep the sun off their eyes. Now, imagine if you knew absolutely nothing about professional golf attire. And to learn more, you decide to attend all the professional golf matches in a single year, and you observe very closely each golfer's outfit. Let's say you observed hundreds of professional golfers on the course, and you saw this same pattern. You could then conclude that someone who is a professional golfer always wears a cap on the course. Therefore, you come to a general conclusion that all professional golfers wear hats on the course. This is an example of what's called inductive reasoning. Inductive reasoning. Inductive reasoning. Let me explain why it's inductive. Inductive reasoning says this: you do multiple observations. Notice here, after observing hundreds of professional golfers. And after you do multiple observations, you draw a general truth. In this case, the general truth was, if you are a golfer, you wear a cap on a course. That was the general truth. That's called inductive information. You take in multiple observations and you come to a general truth. Now, deductive reasoning is where you take a general truth, and you apply it to a specific situation. So look at the difference here. You take multiple observations, you draw a general truth, that's inductive reasoning. Then you take that general truth and apply it to a specific situation. That's called deductive reasoning. Let me give you an example of deductive reasoning. Now go back to the golf example. After multiple observations, you come to the conclusion that all professional golfers wear hats on the competitive course. This what would be your general truth? Okay, now let's say you go out to dinner and you meet a Mr. Tin Vu. Behold, Mr. Tin Vu at a restaurant. And you have this conversation and he tells you he's a professional golfer. Now, at the moment, he's sitting in the restaurant and he's in a full suit and a tie. But you know there's a general truth that professional golfers wear caps when they are on the golfing green. So what general conclusion can you make about his choice of clothing when he's on the golfing green? Taking the general truth that all professional golfers wear a hat on the course, we would apply it to a specific situation, we would say, Mr. Kingu wears a cap on the course. This is an example of deductive reasoning. Deductive reasoning. Inductive reasoning discovers truth. Deductive reasoning applies the truth. Again, inductive reasoning discovers truth. Deductive reasoning applies the truth. I'll have more work on this in class. Ready? Now we're going to talk another aspect of logic here. It's called conjunctions versus disjunction. Conjunction and disjunction. A conjunction is an and statement. The symbol we use for conjunction is a little caret. That is shorthand for the word and. A conjunction is true, and statements are true if only both parts are true. A conjunction is true if only both parts are true. A disjunction is an or statement. The symbol we use for disjunction looks like a V. It's an or statement. Or statements are only false if both parts are false. This will make sense when we actually do an example. Ready? I'd like you to put your finger right here. I'd like you to finger track and read this out loud. Your lips should move as I read this, and your fingers should track. Tina is a freshman student who takes the following courses: biology, English college prep, algebra, global studies, 2, New Testament survey, and a hip hop class. Ready? Knowing what you know about conjunctions and disjunctions right here, and I'd rather you just wildly guess and we'll go over it. I'd like you to determine whether these particular 4 statements are true and false. Pause, work, restart. Ready? Let's take a look here. So this first one, we have an and statement. An and statement is true if only both parts are true. Tina is taking biology and geometry. Well, yes, she is taking biology. It's right here. But it says and geometry. That's a no because she's taking algebra. So although she's taking biology, she's not taking geometry. And statements are only true if both parts are true. So we would call this false. Ready? Tina is taking algebra. That's true. And biology. That's also true. And statement, a conjunction is true if only both parts are true. So this was a true statement. Next one. Tina is taking Global Studies 2 or European History. Well, yes, she's taking Global Studies 2. That's true. Or European History. She's not taking European History. But this is a disjunction. One or the other. And because she is taking Global Studies, a disjunction's only false if both are false. They're both not false, so we would call this true. That's a disjunction. An or statement. Tina is taking geometry or theater. She's taking geometry. That's a false statement. She's taking algebra. Or theater. She's not taking theater. She's taking hip hop. That's also a false statement. A disjunction is false if only both are false. So this would read false. We'll get more practice of this in class. Don't panic. This is your first exposure. Now we're going to review. We have 3 laws of logic. One of them we've already seen before, which is the law of the contrapositive. And then I'm going to introduce 2 more laws, detachment, and then a syllogism. And I'm going to introduce basic symbols here. Okay, we have a conditional here. This is called the law of the contrapositive. The law of the contrapositive. You're given a conditional statement that's true. If you drive a Mini, then you drive a car. And we're going to use the symbols. If P, then Q. A little arrow there. That's called a conditional. Why P and Q? No clue. Just years and years ago, those 2 letters were chosen to be the generic space filler in logic laws, and we're just going to be consistent to what is commonly accepted. If P, then Q. That little arrow means an if-then statement. Okay. If P, then Q. If you drive a Mini, then you drive a car. Let's write out the contrapositive. Contrapositive, we switch and negate. So ready? We switch. We're going to write if. Don't drive a car. Then not drive a Mini. Our conditional is true. If you drive a Mini, then you drive a car. Yeah, it's true, because a Mini is a car. If you don't drive a car, then you've not driven a Mini. That's also true. And the symbol for that would be opposite of the Q. Notice I've switched the order there. Opposite the P. So this is called the law of contrapositive. It says this: if the conditional is true, then the contrapositive is also forced to be true. Here's the symbols. If P, then Q is true, then opposite P and opposite Q and opposite P is also true. This is called the law of contrapositive. Law of detachment. Don't let these fancy names throw you off. You actually instinctively understand most of these logic laws quite easily. It says right here, you start with the general conditional, that is true. General conditional, that's true. Here's one. If you own a car, then you drive yourself to work. Start with that true statement. If you own a car, then you drive yourself to work. So we're going to start with the conditional. If P, then Q is true. That's a really sorry looking Q. Let's try that again. So we start with the general conditional, that's true. So go ahead and just box that whole thing and write true. Now let's apply it to a specific situation. If a mon owns a car, you ask yourself, what is the conclusion you can make about a mon? The general says this: if you own a car, then you drive yourself to work. If a mon owns a car, then why don't you take a wild guess there? conclusion, if a man owns a car, then a man drives himself to work. If you have a general conditional that's true, then the specific is true. Looks like this. If the whole general is true and P by itself is true, then Q by itself is true. The last one is law of syllogism. Guaranteed you've seen this before and you've heard this before. Truly, honest, truly, you've heard something like this before. So don't let the fancy word throw you off here. Law of syllogism is a connector logic. Consider the two conditionals. If you get a job, then you earn money. Second conditional. If you earn money, then you can purchase a car. Take a wild guess with the logical conclusion. Let me read this. You can guess, take a wild guess here. If you get a job, then you earn money. If you earn money, then you purchase a car. Therefore, write something. Most likely you wrote something like this. If you get a job, then you purchase a car. If you wrote something like that, you nailed it. That's called a law of syllogism. Let's just toss in some fancy symbols here. Makes you feel smart when you use symbols. Ready? So if you get a job, that's going to be our P. If P is true, then you earn money. We're going to call that our Q. Here's our second conditional. If you earn money, there's our Q again. Then you can purchase a car. We add a third true statement, R. So if P, then Q is true. And if Q, then R is true. Look at what we have here. If you get a job, that's our P, then you purchase a car. That's our R. We can say, then we can connect. If P, then R is true. That's called a syllogism. You connect two logical statements with a connector statement. In this case, the connector statement was earning money. Okay, you're going to look at these statements and you're going to assume that these given italic statements are true. Then determine which of the subsequent statements, wow, let's try that again. Then determine which of the subsequent statements are also true according to the three logic laws that we just did. Pause, try it, come back. Okay, we have three logic laws to work with here. One of them is the law of the contrapositive. The other is the law of detachment. Last one is law of syllogism. Let's see what's going on here. I'm going to use colors and symbols here to make it easy to track with. So I suggest you use colors as well. If Tom sings, I'm going to make that our P statement. Then the dog barks. That's our Q statement. If the dog barks, there's our Q statement again. Then neighbors get angry. There's an R statement. Ready? So we're going to analyze depending on this. So if the dog barks, then Tom sings. Notice all we did was switch the order here. If Q, then P. That's what we just did. That's the converse. And that's going to be false. Why? Because the converse is not always true. Only the contrapositive is true. Colors really help here. Ready? Let's take a look at the other one. If the neighbors do not become angry, then the dog does not bark. Neighbors angry, that's R. Do not become, so that's opposite of R. Then the dog does not bark. Dog barking is Q, that's opposite Q. What we have here is the contrapositive, this statement right here. It is the contrapositive. Now we learned if the conditional is true, then the contrapositive is forced to be true. You call that true. If Tom sings and the neighbors become angry, let's boil this down to a letter. Tom sings is our P statement. Neighbors become angry is our R statement. Look what's going on here. If P, then Q. If Q, then R, and this is connecting P to R. This is the syllogism. And that is going to be a true statement. Next one, if Tom does not sing, so that's opposite P. Dog does not bark. That's opposite Q. Simply negating, notice the order didn't change. P then Q, opposite P, opposite Q. That's the inverse. The inverse is not always true. Only the contrapositive is always true. So we would call this false. Neighbors become angry, that's just standalone R. That's not always going to be true according to our laws, so we call that false. If the dog does not bark, dog barking is Q, so we're going opposite Q. Then Tom does not sing. That's opposite P. Notice we switch and negate. That's the contrapositive. And that is going to be a true statement. Don't freak out. You'll understand this as you get more practice. This is just a general overview. What I recommend you do right now is verbally walk yourself back through these statements. Take literally 30 seconds a page and just verbally recap to yourself what you learned. If you want, find yourself an audience, parent, a sibling, cat, dog, imaginary friend, doesn't matter, but do verbally review this. Just literally take 1 to 2 minutes and verbally go back through what did we talk about. Use that box as a guide.